NEML time. Let's get your NEML on. All right, we just took the NEML number 3 this week, and it is time to go over it. Now, just like I did in some previous videos, I showed some shortcuts. And so I'm going to do that again. I'm not going to go through all of the algebra and how to solve all these problems, but I'm going to show you how to do some tricks on the calculator since you're allowed to use the Nspire on this. I'm going to skip some steps for some problems. Not all of them. Some of them, though. Like the first one. Let's get started. So here you're given an algebraic equation. Solve for x. Easy. All you do is you go to your solve feature on your calculator, solve, type it in, comma x, boom. You can leave it as a fraction. You can put it as a decimal. It's up to you, but that's it. Number 1, done. Number 2. You want a hexagon with side lengths 1, 2, 3, 4, 5, and 6, but no 2 consecutive sides can have consecutive integer lengths. So 1 can't be close next to 2, 2 can't be next to 3, and so forth and so on. So usually when trying to find these maximums, it's best to start high and then slowly go down. So the highest sum, the maximum sum for 3, if there wasn't the constraint of consecutive integers, would be 4, 5, and 6. So 15 would be the maximum. Now, that doesn't work. So to get rid of 4, 5, and 6, the next logical thing is to go down by 1. Is it possible to get, instead of 15, get 14? To do that, you'd have to turn the 4 into the 3. So can you have a 3, 5, and 6? Yes, because you put the 3 between the 5 and the 6, so the 5 and the 6 aren't next to each other. And it would look like this. Here's your 6, here's your 5. You put the 3 in between it, and just to make sure it still works, you got to put the 1, 2, and 4 somewhere. Well, the 4 can't be next to the 5, and the 1 can't be next to the 2, so this is one possible arrangement. We found one. Let's just move on. 14. That's the answer. Number 3, you want to find the least value k. So we want k to be the smallest, such that there exists k consecutive integers, again, in order, that add up to 1,000. So start with the smallest one, 2. If k is 2, you need 2 numbers that add up to 1,000. Well, they have to average to be 500. That's not going to work, because 500 plus 501 doesn't work, and 499 plus 500 doesn't work, so that isn't going to work. So if you type 3, you would need 3 numbers. There we go. 3 numbers that add up to 1,000, but 1,000 isn't divisible by 3, and the average of these 3 would be the middle number. And that's not going to work. It's like 333 and a third would be the middle number, but that's not an integer. So 3 isn't going to work. Is 4 going to work? Well, if you take 1,000 divided by 4, you get 250. But with 4 numbers, the average of the 4 numbers would have to be 250. And 250 would not fall in the middle here, right? You can't. It's not going to work. You can try it out. Not going to do it. So then what about 5 numbers? Well, the average, 1,000 divided by 5 is 200, and the middle number would have to be that 200, because that's going to be the average of these as well. So if this is 200, so we have 198, 199, 200, 201, 202. We got a winner. It's 5. Number 4. And by the way, here are on the calculator. If you're not sure how these numbers go in, you can divide it. I don't think you need the calculator for this one, really. For the number 4, you're dealing with function notation. You've got this beautiful function here, all real numbers. That means we're basically working with everything except for imaginaries. Don't worry about that. Sometimes you get a lot of words here that you don't need to pay that close attention to. And all values of x which satisfy f of x equals x squared. So let's try and substitute x in for 2t plus 7. You might be like, well, how do I do that? Well, you set x equal to 2t plus 7. This is pretty easy to do, but since we're doing calculator stuff, I'm going to stick with the calculator. So let's do that. Solve x equals 2t plus 7. We want to solve in terms of t, and look at that. That's amazing. The calculator does it for you. Again, pretty easy to do by hand, but just want to show you that it could do that. Now I'm going to actually I'm going to store that as t, so that I can substitute in this value in for 12t plus 37. And if that in the calculator will do that for you, and you get out your 6x minus 5. So 6x minus 5 is what f of x equals. All right, so I replaced this with x. I replaced this over here, so I got f of x equals 6x plus 5, and I need to make that equal x squared. So when does 6x minus 5 equal x squared? Well, let the calculator do that for you too. 6x minus 5 equals x squared comma x. You get 1 or 5 as your answers. Notice the question says, what are all values? That's usually a hint that there's more than one, and there are 2. On to 5 already. We're on 5. Whew, we are flying. This one, basically, you got these 3 congruent circles. That means they all have the same length radius, and they all have centers that lie on the diagonal of a square with side lengths of 8. So let's recall, you have to know your special right triangles. Hopefully you got the 45, 45, 90 down. Oopsies. I need a pen. I got a pen. Got a pen, get a pen. Oh, lost my place. Sorry. Sorry, people. This happens sometimes. So, 45, 45, 90. If this is x, this is x. This is x radical 2. So, if this is 8, and this is 8, the entire diagonal is 8 radical 2. But the diagonal is also r, 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 4 R's actually. And then these two things that are a little bit bigger than R. What are they? Well, if you draw this radii in here, that's R. This is also R. So this is R rad 2. This whole thing is R radical 2. And guess what? You do the same thing up here. This is R. This is R. This is R radical 2. So 4 R's, this one, this one, this one, this one, plus the 2 ends are 2 R rad 2's. That has to equal 8 rad 2. And you might be like, oh my God, that thing looks disgusting. Well, guess what? You can use your calculator. Not saying don't learn algebra, but just saying that you can still use your calculator on this. So you use the solve feature and you say 4R plus 2R rad 2 equals 8 rad 2 comma R. There's your answer. And we are on to the final question, number 6. And how many ways can Grandpa give $100 in $1 bills to his 5 grandchildren so they each get at least $10? This is a combinatorics problem if I've ever seen one. Now, it's a little tricky for 2 reasons. Number 1, you have to know the stars and bars technique. If you've never seen that technique, you're probably going to have a little bit of trouble on this problem. So I'm making a video. I'm going to post it in the comments at the bottom. So I recommend watching that if you do want to learn how to solve a problem like this. But I'll give you kind of a little taste of it here just so we can solve this problem. Now, the $10 thing, that's tricky. That causes some issues. We want to simplify it. We want to make it so that we could give the kids any amount of money, and not $10, because it simplifies the problem tremendously. So one little trick to still make it the same exact problem is let's first give every kid $9. All right. So this kid gets $9. This kid gets $9. This kid gets $9. All 5 of them get $9. So we hand out $45. All right. And now Grandpa has $55 left. And now, as long as he gives everyone at least $1, we've met criteria and it's the exact same problem, but yet it breaks down so much easier. So again, watch my video, post at the bottom. So here's the actual problem in a much simplified version. So you have A plus B plus C plus D plus E equals 55, where A, B, C, D, and E are all a positive integer. All right. Now, it's still not an easy problem because you have to know stars and bars. But what stars and bars tells us is that you got 55 stars. I'm going to use, instead of stars, dollar bill signs. And so I didn't write them all out because I'm not going to do that. But basically, you need to think about, how am I going to break this up in 5 different ways? All right. So I need to break it up where everyone gets at least a $1 bill. So I'm going to set dividers in between these signs. So I could set one maybe here, or the first one could be here, or the first one could be here. Let's say the first one's right here. All right. Well, that means that this is what A gets. So A gets $4 on top of the 9 they already have. So they end up with $13. I don't need to know exactly what the numbers are, but these are the possible places where I set my dividers. And then wherever I set the next divider, let's say I set it here. Well, then this is how many dollar bills B gets. And then let's say C only gets one more dollar, but they already got $9. So they meet the criteria, they get the $10. And then let's say the next one's here, and then E gets whatever's left over. All right. Now, as long as you do this technique, what we end up with is, since there's $55, there's 54 spaces. There's 54 spaces, and we want to put down 4 dividers to break it up into 5 different partitions. So that's just 54 spaces. Choose 4 dividers. That's an NCR problem. It's, again, combinatorics. You have to know it a little bit. But basically, the calculator does that. NCR 54, choose 4. You get 316,251 ways. That's a lot of ways to give out your money. Just saying. Hope you enjoyed it. That's it. I can't get out of here. I'm stuck. I'm stuck in this land of video making. I don't know how to stop you. I don't know how to stop you. I really, 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 really don't know how to stop you. Are you still there? Are you still watching? It's over. The video's over.